All right, so in this video, we're going to look at 10.3, which is polygons, perimeters, and tessellations. We will not be getting into tessellations, so we're just going to look at polygons and perimeters. Polygon is just a three or more sided figure. It's just a general term for three or more sided figure. So something that has 4, 5, 6, 7, 8, and on up sides, that would be considered a polygon. A four-sided figure, four-sided polygon is called a quadrilateral. So if we have something that looks like that, that would be a quadrilateral. Okay, because we have four sides to that shape. On page 368, it gives the names and examples of several different regular polygons. Regular meaning they have the same lengths to their sides. Okay, so some different types of quadrilaterals that we can have. We can have a parallelogram where the two lengths and the two widths are the same, and the angles that make those for the vertices of those are the same. We can have a rhombus, and a rhombus would be more where all four sides are exactly the same. There we go. We can have a rectangle, okay, where again, two lengths are the same, two widths are the same, and the angles are all right angles. So that's the difference between a rectangle and a parallelogram. Is in a rectangle, all four of those angles are right angles. A square would be like a rhombus in that we have all four of the same sides, but again, all four of our angles are right angles. And then we can have a trapezoid, which looks like that. Okay. So two of the sides are the same, but the top and bottom are not. They're parallel, but they're not the same length. Okay. So perimeter, the perimeter of any polygon is just the sum of all of its lengths and widths. So if we took all of the each side and added it all together, that would be a perimeter. So if we look at the example one, it says a rectangular field. This is on page 639. A rectangular field was discussed at the beginning of the section. It has a length of 42 yards and a width of 28 yards. If fencing costs $5.25 per foot, find the cost of the enclosed fence. Well, we want to kind of draw out what's going on. So we have a rectangular field. It has 28 yards for its width. It has 42 yards for its length. Those are yards. And so to find the perimeter, we are going to add up the two lengths and the two widths. So we can say 28 plus 28 plus 42 plus 42. The other way I could think of it is 2 times 28 plus 2 times 42. Okay. So either way, that comes out to be 140 yards. Okay. But that's not the end of our problem. We need to know how much it's going to cost to put a fence around that field. And the fencing is $5.25 per foot. So what I'm going to have to do is change my yards into feet and then multiply that number of feet by 525. So I'm going to set up a unit multiplier. So 140 yards, in 1 yard there are 3 feet. Okay, and then I'm going to go ahead and factor in or put in my price. So 1 foot cost $5.25. So now everything cancels out except the cost, which is what I wanted. And then I'm just going to multiply those things together. So 140 times 3 times 525. 140 times 3 times 5, 25. $2,205 to make the fence. Okay. All right. So let's look at, so I can clear this off. All right. The sum of measures of a polygon's angles. Okay. So now we're looking at adding up all of the angles inside a polygon. And what you need to know about that is that the sum of the angles in a polygon with n number of sides is always going to be equal to n minus 2 times 180. So whatever, and that's equal to the sum of the angles. All right, so whatever number of sides you have in your polygon, you take that, you subtract 2 from it, and then you multiply it by 180, and that's supposed to be the sum of all of your angles. So let's look at an example for that. 1034 on page 640 is an octagon, so we have 8 sides. So let's see if I can draw that. There we go. That's an octagon. So we have 8 sides, so we're going to say 8 minus 2, and then times 180. So 8 minus 2 is 6, times 180. 6 times 180 is 1080. So when you add up all of the angles in there, they should add up to be 1080 degrees. But if this is a regular octagon, so anytime you see that word regular, that word means that all of the angles are the same. So if I have 8 angles and they're all regular, meaning they're all equal, I can take 1080, divide by 8, and that's going to tell me how many degrees each angle is. Okay, so that would be 135. All right, so here's our octagon. So this angle here, A, is 135 because every angle inside that octagon is 135 degrees. And then if I wanted to find out what angle B was, I can look at that and say, all right, angle A and angle B are supplementary when they're side by side. So they have to add up to 180. So then I'm going to take 180 minus 135, and that's going to give me 45 for angle B. Okay. And that's pretty much it. Like I said, we're not really going to talk about tessellations in here. So tessellation is basically, it's just a repeating pattern, kind of like bathroom tiles and that kind of thing. So figure 1035 just shows some examples of 8 tessellations, or 8 repeating patterns of these regular polygons. All right. So I think that is going, yeah, that's going to be it for 10.3. Okay. All right. If you have any questions, make sure you bring them to class and we'll talk about them. If any of the problems as we're doing practice problems that you don't understand or that you don't get correct when we check them, please make sure you ask me about them. Okay. And hope you have a great day. Thanks.